Welcome back. As promised, we're going to be dealing now with molecular compounds. So these are the ones that are non-metals with non-metals and how we're going to name them. So that's what we're doing. We're going to be naming molecular compounds. And once more, that's going to be a non-metal combined with another non-metal. We're still dealing with compounds, so at the end, it's going to end on IDE. And there will not be polyatomics involved on this, because if you have a polyatomic, that means you have an ion, then it's an ionic compound. So these are molecular compounds. Polyatomics are not involved. And this is the format to name a molecular compound. First thing, you're going to do the name exactly as in the periodic table. Let's take, for example, this compound. So the first one is phosphorus. The second one is chlorine, but since this is a compound, you already know what we need to do. We're gonna modify it to set chloride. So what's the difference between ionic and molecular compounds? On molecular compounds, we have to take into consideration the subscript there. And the reason is, this compound can also be like this. And these are not metals, so we cannot use Roman numerals to differentiate it. These are non-metals, right? So what we're gonna do is we're gonna use prefixes to tell how many we have. For example, we know this means that there's one there and there's one there. So since we're doing this one first, that's gonna be mono, phosphorus, trichloride. So mono for 1 and tri for 3. So which is probably a good time to introduce the prefixes. Only one atom, mono. 2, di. 3, tri. 4, tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. And 9 is nona. Those are the ones that you should use the most. We can go past 9, but most likely you will not use those. And this number have been used through a lot of years, so the rules have been modified a little bit. So if you happen to have mono at the beginning, we do not put mono. So 1 is assumed. If it happens to be on the second element, we still put it, but it's changing slowly. So mono, we don't use mono on the first element. So this will be phosphorus trichloride. Let's do the other one. So the other one, once more, we have phosphorus. We have chloride. We have 1, so it's mono, but we don't use the mono. And 5 is going to be penta. So we're going to use phosphorus, pentachloride. So we have 5 of these, so we use penta for that. And that's it. That's the only thing you need to know about naming molecular compounds. You need to use prefix. On the left side, it indicates how many of that element you have, and then the next one indicates how many you have on the next one. And like any other compound, it's going to end on IDE. So let's do some practice there. So on the first one, what do we have? We have sulfur and oxygen, but oxygen gets modified to oxide. We have 1 sulfur, so So that's monosulfur, we don't use it, and 2 oxygen. So sulfur dioxide. The next one we have nitrogen, and then we have iodine, but we're gonna not say iodine, we're gonna say iodide to indicate that it's part of a compound, and it's gonna be triiodide. So nitrogen triiodide. On the next one we have bromine. Remember the first one doesn't change. Fluorine would change to fluoride. And we have 5, which is pentafluoride. Following one is nitrogen, oxygen change to oxide. Nitrogen is 1, but we don't use mono. However, the oxygen is 1, and we use monoxide. So nitrogen monoxide. That changes slowly, but it's still there. Slowly, but still there. And the last one is gonna be nitrogen. Actually, let me do this one down here. This is gonna be nitrogen. Silurium is gonna be selenite. There is 4 nitrogens, so tetra. And there's 4 selenites, so another tetra. So the 4 goes with tetra, and the other 4 goes with the other tetra. So tetranitrogen, tetraselenite. Now let's do it backwards. Write a formula for each molecular compound. Carbon monoxide. So I know I have carbon and I have oxygen. How many carbons? It doesn't say, so it's 1. How many oxygens? 1. So CO, that's it. The next one is sulfur, disulfur tetrafluoride. So I know I have sulfur and I have fluorine. I have 2 sulfurs and 4 fluorides. Chlorine, dichlorine monoxide, chlorine and oxygen. I have 2 chlorines and only 1 oxygen. Phosphorus and fluoride. It doesn't say, so that's just 1. And penta for the fluoride, so PF5. This one is going to be boron with bromide. It doesn't say about the boron, so just 1, but the bromine, you got 3 of them. And the last one is going to be phosphorus and sulfur. Phosphorus is a di, so we have 2, and sulfur we have 5. So that's how you will do it from the name to the formula. And here's your opportunity to review that. So with that in practice, and learning more as you practice more in ALEKS and all that, we can say that we have met this objective pending more practice on your part. So you know how to name molecular compounds. So a new type of compound. This is not an ionic compound. It's a molecular compound, but it's going to have ions. Remember a few minutes ago I told you we cannot use polyatomic with the molecular because that would be ions, that would be ionic. So these molecular compounds are unique in the sense that they do not have ions, but they can produce ions. So we call this a special type of molecular compound. We call them acids. And we're going to see how to name acids that only have 2 elements, and acids that contain polyatomics that contain oxygen. And their name ends on 8, like for example, nitrate, phosphate, versus the one that ends on ite, like sulfide, phosphide, nitrite. That's straight from your polyatomic ions table. So this is the general formula of a binary acid. It's going to be two elements, and it's going to begin with hydrogen. What makes something an acid is that it can produce H+, which is what you get when the hydrogen breaks apart. And we will cover more about that on a close to chapter 8, 9, or 10, something like that. So it's binary because there's two atoms. You're already familiar with what binary is. And it's an acid because it begins with H. So a good way to know is a formula that you're looking at is an acid is because it begins with hydrogen. Where the X is just another element. And you're going to see very soon that most of the time the X is going to be either oxygen or a halogen. Most of the time it's going to be that, oxygen or a halogen. The X can also be a polyatomic ion that ends on 8, like acetate, carbonate, hydrogen carbonate, nitrate, chromate, dichromate, phosphate, hydrogen phosphate, chlorate, perchlorate, permanganate, sulfate, hydrogen sulfate. So those are the ones that end on 8. What about the ones that end on "ite"? Those are going to be nitrite, chloride, hypochlorite. I said that backwards, but you see it. Sulfide, hydrogen sulfide. So depending on what polyatomic ion you're using, the naming of the acid is going to change. So you need to know the names of the polyatomics to see which one you're dealing with. And this is the way it's going to work. Let's say that you have something like this. HNO3. It's an acid because it begins with hydrogen. And then this is a polyatomic ion known as nitrate. If the polyatomic ion that you're using ends on 8, then the way you're going to name the acid is going to be nitrate becomes nitric, and then you put acid at the end. So the 8 tells you that you are going to have to transform this into some kind of ic acid. If it was something like this, then you say it's an acid because it begins with the hydrogen, but the name of this is nitrite, and that's from the table. So what you're going to have then, if it ends on "ite", you're going to have something that looks like this. Ose acid. So you have to know the name of the polyatomic ion to know if you're going to use ose or ic acid. And this will be nitrose acid. So super important that you can look at the formula, recognize that you have a polyatomic ion, find it on the table so you know the name, and if it ends on 8, then it's going to be blank ic acid. If it ends on "ite", then it's going to be blank ose acid. So that ending tells you the polyatomic ion you're dealing with. So it could be, for example, phosphoric acid or phosphorus acid, H3PO4 or H3PO3. We find those in the table in here somewhere if you're looking for them. So let's do some practice. Sorry. So when I look at this, it begins with hydrogen, So I know that the name is going to be something, something acid because it begins with hydrogen. Then I'm going to look at what's the next thing. The next thing is going to be, on this case, a polyatomic ion. And what do we call that ion? NO2, 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 NO2. Right there. So this one is going to be nitrite. So this one ends on ITE. So I'm going to put O's in there. And it's nitrite, so nitrous acid. The next one is an acid also, so it's going to end on acid. However, it's binary. So when I do binary, I'm going to begin with hydro. Then I have an iodine, so hydroiodic acid. So binaries always begin with hydro. Hydroiodic acid in this case. The next one is also an acid. And it's SO4. So SO4 is what? SO4 is right there. That's going to be sulfate. So that ends on 8. So if it ends on 8, I know it's going to be ic acid. And it was sulfate, so that would be sulfuric acid. And the last one is an acid. And it's also NO3 negative. So NO3 negative is going to be nitrate. So ends on ATE. So ic acid. And it's going to be nitric acid. So remember those rules. If the polyatomic that is part of the acid ends on 8, the name of the acid will end on ic acid. If the polyatomic ion that is part of the acid ends on ite, then the name of the name of the acid is going to be blank O's acid. And if it's binary, only 2 atoms, no oxyacid, only 2 atoms, then it begins with hydro blank ic acid. So hydroiodic acid in this case. So time for you to practice. This is just in case, this is a 2 and this is a 3. I know that it looks kind of weird there. Get a 2 and a 3 and a 2, a 3 and a 4. So make sure you do those in there, following the rules that we just learned. And with that, we cover the naming of acids. The binaries or the polyatomics, which most likely are going to have oxygen like phosphate, nitrate, and so on. And that brings us to the last part of the chapter, where we do calculate the formula mass. Now that you know how to write the formulas, given some information, right? How do we find the mass of that formula? And it's very simple. You have a periodic table, which you definitely don't have to memorize. You just have to know how to use it. And on the periodic table, you're going to have the element information, where it shows you the atomic number, which you know is the same as the number of protons and the number of electrons. It shows you the symbol, and it shows you this number here. This number is what we call the atomic mass, and the units are atomic mass unit. So how do we find the formula mass? Well, let me show you this table, and you tell me what we're doing. I got water. Water is H2O, and I'm telling you that the formula mass is 18. I got perchloric acid that you know now how to write the formula. And the formula mass is 99.96. And I have ammonia, which is a common name, which is NH3, and the formula mass is 17.0. So if you follow the pattern, and I give you, for example, hydrochloric acid, that would go on the formula, right? Not under the name. So this would be hydrochloric acid. And I ask you to find for the formula, what you're going to do, you're going to look at how many hydrogens I have. And we practice counting the atoms from the formula at the beginning. So I got one hydrogen. And one hydrogen weighs 1.00794. So we're just going to keep it at one decimal place. So 1.0 atomic mass unit. And I have chlorine. How many of them? Just one. So that's going to be 35.5 if I caught it right there, right? 35.5. So the formula mass is going to be 36.5. Water was H2O. So 2 times 1.0 AMU plus 1 times 16.0 MMU, and that gives you 18. So that's all we do for formula mass. Pretty simple. Super, and I repeat myself, super important. Everything that you're going to do from now on very soon is going to depend on you knowing the molar mass of a compound, and from there doing a lot of stuff with it. So make sure that you practice that. Let me know if you have any questions on it. And that's your daily work. So just to clarify, that's going to be a 2, 6, 12, 6. And I'm clarifying this because it doesn't show that well on my computer, on my screen right now. So that's your daily work. Just find the formula mass using the periodic table. And once you do that, we're going to say that we know how to calculate the formula mass. And therefore, we are done with this chapter. Real quick review. The law of constant composition. As long as you're dealing with the same compound, it doesn't matter how much you have, the proportion on the mass of one element to the others is always the same. You know how to write chemical formulas now. The element that is most to the left on the periodic table is written first. We use subscripts to tell the person that we're talking to how many atoms of each one you have. And that's what we just talked about. And if the element is one of those on the iPhone trick that I gave you on the periodic table or hydrogen, those are always going to be more than one element of the same, so that's molecular. If not, it's an atomic compound. And we saw the difference between ionic and molecular compounds. You now know how to write ionic formulas for ionic compounds when the metal have only one charge, when the metal transition metal have multiple charges, and when you have polyatomics. You know the difference between a common name and a systematic name, and the system is the UPAC system. So we already covered that and this. We just learned how to name molecular compounds. We just learned how to name acids, and we close it up by doing the formula mass using the unit. And with that, we have come to the end. So until next time, review all this, go back and forth as many times as you need. If you need more and you happen to be on campus, you're more than welcome to come to my office or to the Science Learning Center. You can contact the Science Learning Center online through Canvas. You can go into Tutor 24/7, which we're paying a lot of money for the service, so make sure you use it at any time during the day. Or you can go back to Canvas and look at the tutorial videos that I posted, post a question on the question and answer discussion board, or just send me an email. Whatever you need to do, make sure that you truly understand this, because we building the foundation, so you cannot afford to go forward if you are not 100% sure. So until the next time, see you later. Have a great day.